Okay, so let's begin. So a little bit about me. Professionally, I'm holding a role of tech manager and business leader also. Sometimes we call it. And out of my interest, I happens to be Microsoft and C# MVP from the last 4, 5, like 5, 6 years now. And I of course, of late I speak more and blog lit, but I am also a blogger and also mentor some of the folks who happens to be kind of uh, pursuing some technical growth or want to be community speakers and also yeah, I provide some kind of mentorship and guidance. Apart from C# Corner, I also kind of became a co-organizer for .NET Learners House. It is one of the beta group uh, from the .NET Foundation that is out there for pretty much everything from .NET nowadays. So it is part of that. So we have 4 or 5 MVPs in Hyderabad, and we do organize some of the events. Apart from that, technical technology and everything, I do have some non-technical interests like music. Of course, sometimes even I not a great singer, but I sometimes try to sing in my average voice. I prefer I like to visit natural places, mountains, water, trees, greenery, and also spirituality is something is also very close to me. I blog into this site, and this is my Twitter handle. Okay. So today we are going to talk about, since it is for beginners, so we'll give some context about them. What are different container platforms out there? Why exactly we need them? And of course, we'll dive into Kubernetes services. Again, Kubernetes services is not just for Azure Kubernetes service. There are a bunch of other flavors out there. So we'll touch upon what are the other things about, or what are the other options or implementations of Kubernetes services. And of course, then we'll jump into the AKS. That is the main topic of the day. We'll try to understand different, like what is the architecture of the AKS and different terminology that is used pretty often when somebody talks about AKS. If you don't understand those terminologies, it's become complicated and confusing. So I try to put in simpler words so that it is easier for beginners. Then, of course, we'll also touch upon that AKS is not the only thing that is out there for any compute options. There are a bunch of other things, right? So, how AKS is fitting over there? What exactly some of the reasons behind choosing AKS over others? So, we'll have a little bit of community thing study, and then we'll have a demo that how we can create a simple AKS. You can say AKS like. Any application hosted in AKS using Azure CLI commands. And of course, then we can have some of the questions. So that is how the agenda looks like. Let's jump into the container platform. Okay. So what is container platforms, by the way? So container platforms are like, there is a reason behind that, why they introduced. So there was a need in the software development area community that why can't we package whatever we are developing and all the dependency into just one bucket and package and share with others, right? uh, I'll take the typical example that I heard this couple of times from others as well, that remember when the typical scenario when there is a developers out team and there is a testers team, something works in developers machine not necessarily works in the testers machine. So testers may say that, hey, it is failing in my machine, and it's a bug, and developers will say, no, it's working perfectly fine. Then it sometimes it went into arguments mode and doesn't help anyone, right? So how we can address this, how we can solve this? Of course, there could be other ways, but the easiest way could be that, can I have everything put together that is there in developer's machine into one package, like one, you can say, yeah, one package, and give it to the testers, so that testers machine local infrastructure is not playing any role in the something is not working and something is working. So if I have put together all my application code, all my application dependencies, all my required operating system dependencies into one bucket, let's call it container here or package, uh, and I can just name it something, then I can put into some kind of shared location, and then I can give it to whoever I want to give. In this case, example I gave maybe testers. So when testers will get, they will get the exact same thing. When I say same thing, means same application, same dependency, same environment, same hardware, or whatever you call operating system dependencies, everything put together. So when they will test any of those issues, they should not get a different experience. So if something is not working in developers' machines, it should not be, most likely it will not work in their machine as well, and vice versa, right? So there is one example when that basically talks about, or that you know gives the reason that why we may need something called containers. So all the dependencies, all the standardized units basically uh, are put into some kind of package. So all that makes sharing the stuff easier. That makes getting others reusable components into ourselves also. It's also like both ways it is easier, right? Uh, Now coming to the platforms which are supporting that. So the platforms which are supporting this containers stuff. So Kubernetes is kind of most popular nowadays. It is developed by Google. Now it is, of course, every big vendors have their own customized version. Docker is other. Docker is one of the oldest, developed by using this Linux container technology. OpenShift also came up with, Red Hat came up with something called OpenShift container platform. So these are some of the leading, there are more, but these are some of the leading container platforms which are there in the market at this point in time. Okay. Coming to, we look into these things. Now we'll talk more on the first one, that is Kubernetes. So what is Kubernetes then? So Kubernetes, again, one of the container platform. It is developed by Google, and Google has all the ecosystem built in. So they were able to made it more popular. Not to say that others are not popular, but Kubernetes certainly got more developers, I would say, mind share, and also they were able to tell that why Kubernetes is better than others, and also they were able to basically cope up with the time changing needs and developers requirements, right? So they kind of responded on time on developers what developer really want to do, and that in turn like made it that Kubernetes really kind of got a super popular now when we talk about containers, right? And again, it has different implementations, like based on who is doing that. So Google has its own original one, like we call it AK, like GKE, not AKE, sorry here. So Google Kubernetes Engine, they call it. Microsoft got into that their own implementation. They call it AKS, Azure Kubernetes Service, and again, OpenShift also did something called OKD. So they are like different flavors of the Kubernetes that is original out there. Now they just try to customize it based on their own infrastructure and their own developers ecosystem. So this is what the Kubernetes is. You can understand. Now, of course, we are here to talk about AKS, so we'll go like deeper on that. So what is AKS now? So again, AKS is Microsoft implementations of Kubernetes services. What it does is that it simplifies all the orchestration part. Maybe some of us may be understanding what is orchestration here. So orchestration is basically, it is one of the activity. It's just a name put for something you want to sequence it, you want to automate it. You have bunch of containers. So and their interactions, basically how they interact, how they talk, how so something of that, we call it orchestrations. You might have also heard this word in terms of somebody comes with a desktop background, like business services kind of orchestration. So orchestration is something that you're trying to automate business services. Sometimes you're trying to automate different web service communications and things like that, and also how they you want to control as well, like starting, stopping, and things like that. So this is called orchestration. So Azure Kubernetes Service is basically you can say orchestration engine for containers. In simplest basically way you can put it like that. It is managed, of course. It is not the purest Kubernetes, because in that case you need to handle so many things yourself. Managed, whenever we say it, it always means that there is some abstraction out there that makes your job simpler, and and you know and basically you need to focus on something that you care about, not the entire thing end to end, right? So it's a managed Kubernetes in that sense. And of course, it's managed, so it simplifies your container-based application deployment and stuff, right? Basically, one more thing that there were other. If you go back to the couple of years, so we do have even here, right, Docker also, and few others also. So Kubernetes basically targets not a large, you can say, volume of containers, means something complex, right? For a simple application, if you're using AKS, you can use it. Nobody will stop you. But whether it really makes sense to have AKS cluster for a very simple application, may not be, right? So it's like you have, but whether you really need it. So if you ask like when we really need it, so the best you can scenario to use it like when you have a little bit complex applications, like it has bunch of containers, because if you have bunch of containers, then it's like it makes sense that you are orchestrating it. Otherwise, if you have just a one container, then if you're using AKS, it's like not the right use of AKS. So you can use it, but it is not, you're not using the right capability of AKS. You end up paying more because everything comes with a cost. So in cloud world and in containers world, we also need to be a little cautious about how much we are spending, and hence, we should be using something when it really makes sense, and the study needs to be done, assessment needs to be done, that whether it's really required. And this is one of the criteria that if you have a simple application, one or two containers, you may not be it may not be the great choice. There are some other options also, like Azure Container Instance, ACI, in case somebody knows. So those are some of the other options that you may choose. But if you have bunch of containers, then I think it's difficult to manage, and then AKS is the right choice because it provides orchestrations, management kind of tooling, so you can take care of your containers pretty well. Okay, moving further, so let's try to understand a little bit on the architecture and terminology that is used. Okay, so this is how it is structured, right? So since it is a managed service, so you means users, developers can't really or shouldn't be like caring about how it is behind the scene. Means how Azure took care about management part or admin part, you can say. So it has certain things that it is taking care of itself, and rightly so, because otherwise developer will be distracted with something admin side of the world, and they will not be able to focus on the things that they should be focusing on. So Azure is taking care about like API server schedulers, like different timing you want to schedule. There's something called etcd. We'll look into some of those things. Controllers manager also, there is something. So these are some of the entities that Azure is managing itself, and you don't need to really bother about it. What you need to care about is something at the right side. That is customer managed. That is means developers or users managed. So you could have Node. As you can see, Node, there are different instances of Node, of course, you can create based on the requirements. So one node typically have these three or four things like kubelet, command line things, right? That will also have them when we look into more. Container runtime. You also need runtime to run something. So it's like .NET runtime we have for .NET. So like that, container runtime also, we should be there in the developers area. And container is something but running instance here, and you need kube proxy as well for some networking requirements. So these some of the things at the right side that developers needs to understand more, and they need to plan their deployments accordingly. Left side of the world is kind of nice to know, but even if you don't know, you can still manage. Okay, now let's try to understand what these some of the terminology means, because they are used pretty often, and if you don't understand, it's like goes from the on top of the head. So better we try to understand in a simpler way. So what is control panel, right? So control panel is the entire stuff of these, you can see left side. We also typically like generally call control panels because it is controlled by the Microsoft in this case. So it has some of these things, right? So what is API server? So see, API servers is something that that helps you to talk to the Kubernetes, you can say cell or Kubernetes engine, right? So nowadays, like for everything, we have pretty much APIs, whether it's like a database we call about Mongo, Cosmos, how you interact, you contact with APIs. So like that, even for maybe when you want to interact with, you can say Kubernetes engine, you should be using API server. So API server exposes some of those APIs to manage some of the things, right? What is it is etcd here? So etcd is basically a key value pair kind of stuff to maintain the state and configuration. Configuration typically we store in this kind of scenario nowadays more in key value pair, whether it's Azure Key Vault in Azure to store some of the things, secrets and all. In this case, you can say instead of Azure Key Vault for AKS we have etcd. So it helps you to maintain or save different state of the Kubernetes cluster, and of course configurations of the settings that is required to be stored. It takes care about that. What is scheduler? Scheduler basically is, as the name suggests, it spans something or it triggers something. So it is a scheduling engine that basically, it helps you to, okay, which node you should be starting and when, right? And what is the frequency? What is the, what time it has to run? So all those scheduling kind of scenarios, basically, or scheduling kind of requirements, scheduler takes care about. What is controller manager here? So of course, as with everything else, we need some management system that looks into all the nuts and bolts and do the right things, like trigger something if something is not right, send a mail, send the notifications, okay, provide some recommendations and do some logging, all those stuff. So control manager takes care about overseeing the different platforms. Like we'll talk about this various like as we go further, like what is pods and all, right? So what are different pods are there, whether they are in good health or not. If not, then whether users are notified, right? So some of those things. So like managing, overseeing pretty much everything out there, and basically doing the right thing, doing the needful, like so sending notifications or sending something, mail if you configure. So it's like managing pretty much everything out there. So that is the job of the control manager. So that is the left side of the world, like that Microsoft takes care itself. Coming to the right side, where developers need to care and developers need to understand in detail. So let's go on those. So nodes are like you can say one instance that helps you to run the application. You can have as many as you wanted based on the uh, complexity, replication requirements, all those parameters in mind. So basically, it's run. It's like one instance, you can say, right? What is kubelet? So it's basically, it's one of the Kubernetes agent, and that that gets from request, right? As you see here, there is an arrow. So scheduler tells you that, okay, please execute this. So kubelet does the real execution job, that it gets the notification from the scheduler. So kubelet executes that. That is basically, orchestration request that it gets from control panel or schedulers. So basically, it try to run that. So it's like one of the Kubernetes agent that processes the request, that it gets the request from scheduler. So that is a kubelet. Scheduler. So coming to this, right? So proxy, as I said, like it takes care about networking piece of different node and pod. So when you say node, so node has again container, will have pods. So that networking requirements about virtual networks and those things will be taken care by this one. Okay, so proxy, we just talked about that it takes care about networking part for each node, and of course in containers we do have pods, so that will be done by the proxy. Runtime, as we were talking, runtime is something the foundations of any system, so it will have DLLs and dependencies that requires it to run. So basically, all the runtimes that spans or that triggers the containers will be also be should be there in the here in this case, right? So it will to manage. Here are some of the important terms, and now coming to the you might have heard this pod thing pretty often. So before going forward, let's talk about what is node pools. So as if you look at this diagram closely, so as you see, like you can see two instances of node, because you configure that how much node you wanted. It is all application requirements. So if you want more availability, you will need you will want to get into more number of nodes. Sorry. So each node will have its own containers, and of course, typically the requirement is that, not the requirement, but the guidance is that you just try to keep one pod in a container. But there are some complex scenario when you may want to have a more pod also in a container. But typically speaking, like you can have like one node you have, and these are some of the stuff that comes into that. So one node have a container, and also it has one pod. So what is node pool then? So node pools are basically, like set of pools, right? Like set of nodes that you have initiated for your own requirements, for your own application deployment, that how many nodes you want for it to work. Like different instances of node, you can say in this case. So all those instances put together call as a node pools, right? So they're kind of pooling, right? Yeah. So they're like they have some linkage so that basically if some node is kind of getting down, so other can pitch in and things like that. So from the pool you can make use of those nodes. Coming to pods, so it's like it's like instance of your application. It's like one to map. I was saying that typically a container has one pod in most scenarios to make the configuration simpler. But in some cases, you may even have the more number of pods, more than one pods in a container. So coming back here, so in this case, yeah, where my mouse is there, right? So here, typically you have just one pod, but you can have more. So it's like running instance. If something is running, so that is typically called as a container or pod in this case. Here are some of the terminology that are used pretty often, and the typical architecture, like how this AKS is designed, and what you should be looking at, and what you may be. It's like good to know, right? So some of those things. Okay, now coming to that, how AKS is kind of fitting in the overall ecosystem of the compute the options that we have, right? So let's look at this. Has been important diagram and useful diagram I refer often. So if you look at here, so yeah, so look at here. So it is right here. So when you before you reach here, so you already might have explored these options, right? So where exactly you want to come here? Let's try to review. When you want to build new or migrate, I think in both cases it comes. So basically, do you need full control? No, of course not, because it's a managed service. So and then you really don't want to have a full control. You are good enough for a required control that is that developers may need it. It is not a high performance computing, of course, that like otherwise you may end up going into batches. So it is not a high performance thing. It is for mostly for application scenarios, not like high performance, like a lot of compute options and it's like real time, all real time kind of thing. No, it's not for that. Of course, it is for microservice architecture. we'll talk more little as we go further. It is like nowadays people say that okay, containers and microservice architectures are like complementing each other. So they're like almost become synonym that if you're using microservice architecture, you should be using containers. Which container is something that you can determine based on your requirement, but typically some containers. It is whether it's like event driven and short lived, not really. It is not an event driven thing. For a event driven, that you have something else, right? Uh, Full fledged, yes. Here is a remember I was talking about container stance and this one. So container stance will be or should be used when you have simpler scenarios. Application is not that complex. Then then I think as the name of this count is container stance. We call it ACI in short. And if you it is not if and if it's a complex one like you have more than 10-20 kind of containers and you want to manage all those things, and it has mix of open source and .NET as we use more often nowadays with .NET Core came in operations right from last 2-3 years or 4-5 years rather. So considering all those cases, then you will basically you should be using AKS, right? We'll look into the right side of the things. Coming to the left side where we are not building new, but rather we want to migrate something. So is it for lift and shift approach? Not really. For lift and shift, you can simply use older things like Azure, like virtual machines you can use, or you can have some simpler implementation like app services maybe. It is not that it is not complex. At the same time, it is not simpler as the maybe app service would be, right? So it requires some settings, configurations, and some kind of experience also as we go. So basically, it is not a choice for a for this one I was saying that for simpler applications, and and if it is basically if you're going if you want to kind of containerize, of course, then only you go for this one. So basically, whether it's a new application or it's a migration, if it is requires containers, then you should be considering the AKS in this case. Okay, going further, let's look into the demo. So for what I have done is I have simplified some of the things so that we don't lose time on this one. So I'll be kind of I'll be coding or whatever you call it, working along with you so that you also understand how it looks like. So basically, I'll be using there's something called Azure CLI commands, and that is easiest way. Of course, people who prefer Wizard stuff, they can also do those similar things from Azure portal. But folks who likes to see these things like they want more control and they just likes to type, so for them CLI is still a good option. So let's basically try to do that. So I do have one, but I'll create. I think I have good time left, so I can create along with you. So what you do? Try finding CMD, run as admin because you may need to do something that requires admin permission. Okay. Now what you do? You just hit AJ login. Okay. What it will do is it will go to your go to your Microsoft personal like Microsoft account. In this case, it's my personal Microsoft account. Yeah, it is pretty simple. So you're logged in. So it read all your credentials, and now uh, look at here. So what it has done? It has done a couple of things. It has logged in. It gave you a instance. Basically, you can say secure instance or logged in instance, so that you can run your commands, and you can basically talk to Azure from this window, right? That's what it means. It is telling that I have 2 subscription at this point with me, and no, it is you can go ahead from here. So that was the login. Now, of course, as we know, for anything that we try to do in Azure, we create something called you can say umbrella or parent or something, whatever you want to call it, but the technical name is resource group. So try to keep all the stuff that you built under that resource group. So what I'll do is I already have this what do you call AKS demo, so I'll just change the name. I'll make it to here so that it is creating from scratch. So I'll create one resource group. Um, okay, so let's do that. There are a couple of things that we need to take care of manually. So, and hence I'm just preferring that you do that. So you will learn it. So what it has done is that, okay, it created it succeeded, as you can see here, the JSON response, and it has created AKS demo RG2, right? Okay. How can we see if we want to just really make sure that it is also done? So what we can do is we can go here. Okay. So if you look at here, it should have been done here. Okay, it is not coming, but it should be coming here. Resource groups. Yeah, it came in, right? So AKS demo RG was there already, and this has also come up. So it has created. So basically, what I'm trying to show that whatever command you are executing from this one, it is also reflecting the portal because it is hitting the the Azure backend. So it is reflected in here as well as here. Okay. So a resource group is created now. Now there are a couple of things that you need to take care. So there's something called operations management and operations insights that should be registered. So by default it is not. So since I know that by default it is not registered, so I'll be registering here. And what I'll do is, yeah, I think on this, since you're working on this one, so okay, let me check it, because if it is happening for your account level, then I think it may be registered. So let me quickly see if it is registered already. If not, then I'll again register for this, the new resource that I have created. So let's check it, that these two okay, so I think it is registering. Okay, let's do this as well. Now operations management is in, and operation insight is the other one. Okay, good. So now, okay, let's move on to next step now. So basically we have registered these two things. Now what we need to do is we need to create an AKS cluster so that we can host our application over there. We can host our application means we can host our containers. So in this case, your application would be sitting in the containers, and container would be AKS, of course, don't host the application directly, rather it hosts the containers. So it will be hosting the containers. So before we host, we need to create a cluster. So I'll create a new cluster here. So I'll use basically resource new one that we have created. I'll also name it cluster 2 just for uniqueness sake. Okay. Fine. I just want one node. Remember we were talking about node, how many node instance you may want to have it. For a demo, doesn't make sense to have more than one, but for real world application, you can have based on how much you want, like speed and scale and everything, right? Okay, so these are important things. So as you can see, it is Azure, it is a CLI command. It is creating resource group. This one I want to use, and this is the name I want for my AKS cluster. I just want one node, and of course you just basically for this, right, for add-on monitoring, we have just registered these two just for in case you're interested. That's why had to do that. We had to do that because we are want to enable monitoring, and for monitoring to work, you should have these basically namespaces registered in your source group. So, and hence we have done that. Okay, so now let's run this. It may take few minutes, but that's fine. Okay. So yeah. So while it is doing, so one important thing that I would like to mention here that due to the architecture at this point how it is. So one resource group of course we create, as you can see here, we have created one source group. One more resource group will be created by the Azure automatically. You may argue why. Of course, I also had the same question. Even I have now the question, but you can consider this as one of the constraint or one of the things that so far it has not been sorted out. They are saying that to keep the basically keep the AKS resources. Let's have a one more source group. So you should be aware of it, so that when you are cleaning your resource groups, just look out there that there may be one more resource group out sitting and eating your bandwidth and your balance, right? So you just to be a cognizant of this, that when you create clusters, one more source group also gets created. Okay, the name you will find some similarity in names, and you can figure it out which is that one. But just to kind of try to look into and make a do the right decision whether you're cleaning or whether you're using it. Okay, let's see what's going on here. Okay, it's running. It is again creating a cluster. It takes some time, few minutes, but that's fine. Okay, after that, what we'll do is that we'll try to get a credential. So basically, one more CLI we need to basically have it, because this is the Azure's CLI, and when you are running, when you want to go inside that container, you may need to have the Kubernetes CLI, because you will talk in Kubernetes CLI framework. Azure CLI may not get into that inside containers, and it containers may not understand the Azure CLI command, right? Azure CLI is sitting outside or of the Azure framework, right? So to be able to read or to be able to communicate to the containers, you may also need a this one, this QCTL, and that is a Azure, there is a Kubernetes CLI. So there is an option to, there is a command to do that. And here I was saying that you may need to add this path manually yourself, and it is not yet automated. So that is something that at this point, because it installs something in your machine, and if you're using CMD, it like any other things, right? If you are not adding that into your environment variable, you need to get into that path where it is installed, and then you need to run it. Otherwise, like on a contrary, if you add that path into your environment variable, right, you can run from anywhere. Right? It understands the path that I need to run it. So that setting you need to do yourself at this point. Let's see. We're still running. That's fine. In the meantime, I'll show you how the settings looks like, so that when we do, we can move faster here in this step. So what I'll do is I'll open what I call environment variable. So here it is. So I'll open this one. I think most developers should be like developers with this what we do. So you need to go here. You need to go to path and here. Look at here. So this path, right here, it basically stalls your data, like not data, sorry, stalls this one, this Kubernetes CLI, and to make it work end to end or make it work from any path, you need to add this path here, right? So that's what I have done, and in your case, you also might need to do that. Okay. Oh yeah, it's done. Nice. So it has created the cluster, and as you can see, okay, it will give you bunch of information, because cluster comes with, it's like huge things in its own. Let's look into what all things it has given us. Okay. Yeah, so this was the command that we ran, right? Now it has ran and it is popping bunch of information that may be out of the scope of this talk. There are so many information that out there, but at a high level, you can say that it is enabled, and so basically it creates different profiles of agent pools. And what else? Yeah, identity profiles, because the cluster has to, it needs to have some sub component also gets created along with, so and hence it does all those things and just gives you the response, right? As you can see, bunch of other information that is. Yeah, and this is the one that I was talking about, if you recall, that it creates one more resource group for you to keep the Kubernetes resources or Kubernetes assets. So this is the resource group that it is created without your permission, but you should be aware of it. So that you, when you clean, you know that you need to clean here. So yeah. Some of the other stuffs, right? It takes care, it uses the default options like it is tier free and name and all. So the Kubernetes cluster has been created. If you want to look at into visual form as well, so yeah, of course we can look into. Just hit on the source code that we created, and it will give you the what all things that. Yeah, look at here. So AKS cluster, AKS demo cluster 2 is part of what? AKS demo RG2 that we have created. So it is also replicated over here. Okay, what next? So we got it, we got cluster created. Now let's do more. Now we need to basically we can do this step, maybe we can interchange also, it doesn't matter much, but start to understand this one. Okay, so this is basically, this will install the CLI as I was showing you. Uh, it will install, let's, since we are showing, let's quickly do that. Yeah. Sorry. So AJAKS install CLI, you can also write AJAKS CLI. So it's like AKS CLI. So it will download from this is the look at here. So it is like Google is not leaving its footprint. So because it is originally came from Google, right? So it is downloading from googleapis.com and it is downloading over here. So this is the path. If you recall, I added this path into the environment variable I was showing you, right? So that you can access this cube control commands from your any path in the CS command prompt, right? So it has downloaded this one. Now it is downloading client. Client may not be used for you directly, but it is like it has some dependency. So it is installing, like it is downloading right now. Okay. We have few steps left. We are almost there. Should not take much time. It gives some. So there are a couple of options that if you don't want to uh, add into environment variable, you can also make, you can say, temporary, make it like instance wise setting also you can do with, there are some commands that it will tell you. I typically prefer the stable way, like I don't need to do it again and again. So I have added into environment variable is like one time thing, right? So, but if you're not interested in adding to, we just want one demo and move on, then you don't need to add into the environment variable. You can simply run the command. So it will set environment path, like it will set just for this instance. Once you close your command prompt, it will go away. Okay, so while it is happening, let's quickly look into what is next out here. So we'll basically get a list of cluster nodes. We'll see, like, remember we have created one node here. If you look at this command, node count one. So it should basically tell us that, okay, I just have one node here. I'm not sure that it will take. It should not take because we have just But let's see whether it is taking the other clusters node also, or it's just taking the one that we have created. Then the most important part will be YAML file or YAML file, whatever we call it. So this file is something that keeps the deployment or containers information that you want to deploy. So in this case, I do have containers already. So I'll be deploying into the AKS. So let's talk about quickly. Let's see. Okay, it's done. Okay. So if you recall, I was talking about that if you just want to do only once, then this is the option that I have done. Go to environment variable and do that. If you just want to make sure, if you just want to do just for one go, you can also run this command like this, so that when you run the queue control commands, it understands, right? So any of the option can be chosen. Okay. So now this is done, and now what we'll do is that we'll try to see whether it is really done and whether it's understands like how many nodes it is are there in that cluster. So whether it is understanding that or not. So I can also write like queue control get nodes. Oh yeah, so it is telling about the node that we have you know we have generated, and it is ready. It is fine. Great. Now let's talk about the YAML file. So this is a simple application that I'm planning to deploy into AKS. So I do have that YAML file. Let's quickly review what we're doing here. So uh, let's review and then we'll talk. So I have this one. So let me open this in Notepad++ because it's easier to read. Yeah, do we have? Okay, it has some color coding already. So as you can see, this is the YAML file. It is like, you can say, if you want to relate it, it is very close to the Azure that we create source file and all, right. So you just define like how many nodes, how many pods, and everything you want from what container you want, how much CPU and memory, all those things, right? Into this file, and you give the path of this file, and your the AKS cluster would deploy your containers of the configuration that you will be giving, right? So what we are doing here, we're doing two things here. So if you look at here, uh, basically, we have one voting applications that is built in Python, but it's a container, so it doesn't matter. It is in this application is sitting in a container. So one container is for basically one is for this one application, and one is for Redis to talk to. And for services that we have used is that one is for like Redis, of course, and one to like how the voting application is you're showing to the internet, and you should be able to talk to the Redis, right? So for that. So as you can see, there is one application here. So, you know, yeah, this is the one application. And if you come down, the other one is here. So this is the, yeah. So look at this keyword. It is very important. So it is a service here, right? Let's see like I'm starting. So one is what? Deployment. It is service, and again deployment and service. So what we're deploying here and what is service? Remember I was talking to that we have two services and two deployments. So same thing is happening here. So here there are two deployments and two services, right? So for services, of course, we need to open a port, and we should be defining the port, and that's what has been done here. So this is the port for services, and this is linked with this application, and same goes with here. Here you have this application, and you know port is also defined 80, right? So this is how this YAML file is kind of configured. there is a lot more to understand on the ML file, and maybe the one session just we can spend on this one. So it's like so many things you need to understand, like spec and metadata and bunch of other things. But since we're talking about the overall, like generally, then I think you can understand like the two deployments that we are doing as services, and we'll be referring this one into the while we deploy the application. So let's do that. Uh, so how to deploy it? So we'll be using this apply command that comes off this kubectl CLI, the Kubernetes CLI kubectl. So here I need to give a path, right? So this is the path where I'm telling that how many what are my containers configuration, and please use that configuration and deploy into the Kubernetes. That's what I'm trying to say here. Okay, so let's do that. So yeah, okay, so fast. Yeah. Now it is like it may take some time because you deploy it, but whether it's really spin up outside or not. So here, if it is done, so we can keep hoping that until we get public IP. Because until we get the public IP, we can't really see in the internet, right? So this command will help you whether it is readily available or not. Okay. So I'm doing some mistake here. What mistake it is? Okay. Let me try this one. kubectl apply. Okay. And again, let's try to kubectl get services. It should be telling us public IP. Okay, so it has Azure word front. It is okay. Oh, are you doing Kanban? Okay, so sorry for some trouble, guys. That's what happens. Uh, do I have this path? Okay. So it is basically okay. It is not giving you some reasons. Let me see this, and should be telling us this one. Mhm. For some reason it is not doing. But let me open up something that is I have done recently. Something similar. For some reason it's not happening. So this is the cluster that is installed already as you were doing, and basically you should be able to run this. So let's try to run this. It should be showing us this public IP. Okay. So by the way, if you are not interested in like if you prefer not deploying something in local, you can also use the Azure Cloud Cell. So it has all the dependency in it already. So you don't really need to deploy them into your machines, right? So that is one. Let's see that if this is working. It may not work. Public IP is not exposed. But it gives the in that command somehow it is not coming. Let me quickly check if it is somewhere. Okay, it is similar. Let me save this. May not work. Okay. But yeah, when you run this typically, you will get public IP, and once you hit this one, it gives you this path. For some reason, it is not working. Fine, guys, it is not working at this point, but this is how we set up actually. You know, these are some of the commands that we take care, and this is how we deploy any containers into the AKS. And what it does is that it gives you the public IP once you do that, and once you run that, you can use that public IP, and it will work normally. Okay. So somehow I'm not able to find this public IP that I got 2 days back, but yeah, that's how it works. We'll talk more at some other point on this. Okay, that's what I had. What else? Yeah, that's what I had, guys. Thanks for. I think I'm also on time.